You have Wireshark installed on your computer and you're ready to start capturing network traffic. Let's talk about how you actually connect to the network with your computer to capture that traffic. Enterprise networks can support a range of different types of traffic, different types of users, and have many different types of network nodes. In this simplified illustration, I have my user's device on the far left, I've got a switch, a router, and on the far right, a server. Before you start to capture network traffic, I would also recommend that you get a map of your network. Because the first question you have to ask is, where do you capture your network traffic? And the answer to that question is that it depends on what your goal is for capturing network traffic. For example, let's say you're troubleshooting a problem where a user has said that the network is appearing unusually slow, and you have determined that only this user appears to have a problem and other users on the network do not have a problem. In this scenario, it would make good sense to capture the packets as close as possible to the end user. You can then look at the data going specifically to and from the user's computer, and you can determine things like round-trip delays, what services and applications are being accessed, etc. If, however, you determine that this user is not alone, and indeed many users are complaining about the network being slow, and in particular perhaps they're complaining about a particular application or service that they're using on the network. In this scenario, it would make sense to do your network capture closer to the server that appears to be having a problem, rather than capturing lots of different packet captures from lots of different users. You can just do a packet capture close to the server. Alternatively, if you determine that many users are complaining that the network is slow and it doesn't appear to be a particular network service or application, then it may be desirable to do that packet capture in the network at a location where perhaps you've determined most of the traffic would transverse. A general guideline when you're capturing network traffic is to start as close as possible to the location where the problem is occurring. If you're not sure where the problem is occurring, then you may need to capture traffic at multiple locations and analyze that traffic until you can narrow it down to the portion of the network that is causing the problem. Now you know where you want to connect, the question becomes, how do you connect to the network? And there are four main options, and I want to take you through those on the next few slides. Option number 1, install Wireshark on the computer that you're trying to troubleshoot. For example, the user that complained that they had a problem, or the server that appears to be a problem for several users. The clear advantage of this approach is that you don't need to configure anything in the network. You simply need to install Wireshark, like we did in the first module of this course, on the user computer or on the server. There are a couple of disadvantages. Not only may you not have access to the user computer or the central server, that installation and packet capture activity will actually impact performance. So if you're troubleshooting a performance issue, installing the tool on the platform itself may not give you the most accurate of results. Biggest problem is that this just doesn't scale. It's just not a good solution for troubleshooting a problem in an enterprise environment. This might work well in your home network or even in a small business, but in a large enterprise network, you cannot be installing Wireshark every time there's a concern regarding a user device or a central server. Option number 2 is to insert a network tap into the network. A network tap is simply a piece of hardware that's inserted between two network nodes in order to capture the traffic between those two nodes. The advantage of a network tap is they don't impact the traffic between two network nodes, but at the same time you can see all of the traffic that goes down that connection. Network taps are quite often used in security environments where you need to monitor the line, but at the same time not be easy to detect there's a tap on it, because network taps do not have any physical or logical addresses that can be found through a network sniffer. However, it's not very desirable when you're just wanting to sniff the network for performance or monitoring reasons, because one, when you install the tap, it actually breaks the network and then you have to reconnect it. And so for that time where you're installing the tap, no traffic can go down between those two nodes. And it also doesn't scale very well. In an enterprise network, it may not be feasible to put a tap on every network connection between two nodes. Option number 3, insert a hub on the link that you want to monitor. So in this example, we want to monitor the traffic between a user device and a switch. And by inserting a hub in the middle, the hub will broadcast everything that it receives from any of its ports out to all of the other ports. So you will see traffic that the computer is sending to the switch and out to the network, and similarly traffic from the network through the switch to the user device. This is my least favorite option, but it does have some advantages. Hubs historically are for connecting different segments of a LAN, and so if your hub has multiple ports, you could be monitoring multiple segments on that LAN. The disadvantages are that you may insert traffic into the network, and if you're trying to monitor for performance problems, you want to avoid inserting traffic into the network. For example, your device may be sending ARP messages or DHCP requests. So avoid this technique if you're looking to monitor the performance of the network, because if you insert traffic, it will slow the network down. Option number 4, enable port mirroring on the switch. Port mirroring will take all the packets from the port that you want to monitor and copy them and forward them to another port. You can connect your computer to that other port, and then you will receive all the packets that are going through the port that you want to monitor. Port mirroring is a very common technique for monitoring network traffic, and the key advantage is that it captures the traffic coming both into the port and out of that port. However, there are some disadvantages that you should be aware of. First, not all switches can do port mirroring, and those that do need to have a port available that can be used as the port mirror. As port mirroring is capturing the packets, copying them, and then forwarding them to another port, it does consume switch resources. And in a heavily loaded switch, this could impact performance. You will also need access to the switch or be able to request someone to configure the switch for you. And care has to be given on how the port is configured, because remember, you are capturing the packets both in and out and then sending them on one port. For example, if you're monitoring a full duplex 1 gigabit link, you could have 1 gig going out and 1 gig coming in, which means that your mirrored port needs to be able to support a network speed potentially up to 2 gig. If the switch cannot forward the traffic fast enough on the mirrored port, then it will result in packet loss. But as I said, even with these disadvantages, using port mirroring is the most common approach to monitoring network traffic.